Hello, everyone. Thank you for joining this webinar about data analytics. Today, Nick from HeliCloud, Herman from SoftwareOne, and Angel from Amazon Web Services will each tell you more about the topic. After the presentations, you can ask questions in the questions box. Throughout the webinar, you will be muted, and after the webinar, we will publish the video on our YouTube channel of HeliCloud. Please subscribe there to get updates. We'll just wait another minute for all attendees to come in, and then we will start with the presentation of Nick. All right, Nick, I think the floor is yours.
Well, thank you for that. I've got some pretty little slides here. So the agenda for today, I'll be very quickly introducing you to the wonderful world of data analytics. What can you do with it? What's something I can demonstrate to you in 10 minutes? Then Herman's going to take over. So what do you do after? And then Angel will look into what can AWS do for you when you want to get more out of the data you already have. So I'm Nick de Weijer. I am a technical design authority within HeliCloud, a cloud consultant, and my career has mostly been in the financial sector. I've worked for Rabobank, which is a Dutch, one of the big Dutch banks, for Exact, which creates bookkeeping software, and now I'm with HeliCloud doing a lot of migrations, and currently I'm working from a couple of customers to build data lakes, which is very fitting for this webinar. What is data analytics? It's often already things you already have, but you don't know what to do with it. Web servers do a lot of logging. You have logging in your sales, in your ERP, in your point of sales devices. A lot of logging and a lot of data is created and stored every single day. But a lot of that is just stored and not a lot of it is being done with it. So doing actual analytics on data, taking that raw data and getting value out of it, that is basically the core of data analytics. So within AWS, there are in my opinion, three core components to start up a data lake, as you would say. Because a data lake is nothing more than a place where you put raw data and take that data and turn it into something valuable. S3 is where you store it. Then you have Glue to manipulate it. And then you have Athena to search through it. There's way more, but Angel will pick that up later. So I'm just going to zoom in to what can we do in a very short time. These services, I did want to mention that, is pay as you go. If you are not using it, you're not paying anything. And you scale linear to what you are actually putting in there. So I'm very much fan of a show, don't tell. So I am going to demonstrate how to quickly get some value out of some raw data. Over here, I have the AWS console. I'm set up in Ireland, and I already have a couple of tabs open for S3, for Glue, and Athena, and we'll visit them in turn. I have prepared some data. I've created a HeliCloud web app folder bucket that has some raw data in there. So let's quickly take a look at that. The data here is JSON in type, but these are single lines and they're nested, and it's just very much raw data that you really can't do much with right out of the gate here. But we have a bunch of it, so let's start using it. I'm going to go to Glue, and we are going to crawl this data. So I'll explain to what Glue is in a second because it'll take a while to run. So I'm just going to set it up right now. No, we're just going to call it user data crawler. It's going to crawl through S3. Let's pick the bucket that I just showed. Next. No, I don't want another store. It needs rights. So let's create a role that's allowed to do this. Next. Create a new database. We'll call that user data as well. Next, next, finish. And it's helpfully saying, should I run it now? Yes, let's run it now. So while in the background this is running, what's a crawler? So I have all this data in S3, what I just showed, and it's relatively unstructured data. It's got a JSON nested format, but that's about it. The crawler that I just started is going through all that data right now. It's looking at it, what do we have here? And it's going to start parsing through it, and it's going to extract and create a catalog that's going to hold the metadata of this raw data. So it's going to become easier to search through. I have about 5,000 records there, and it shouldn't take more than about 40 to 60 seconds for this crawler to actually do its thing. So let's take a look. It's already finished. It's created one table. So let's take a look. We have the table, and within it we see we have a user, and it has the entire structure here of everything that was already in there. So if we now pop into Athena and refresh this, we see that we have a table, and let's preview this table. We're doing a quick query. Let's refresh this. It very much wants to have this specific bucket. So let's give it that specific bucket. There we go. And we see we now have data that we can actually search through. But as you can see, these are still the single lines that we saw in the JSON file we had in S3. And believe me, this searching through this quickly is not an easy thing. We can transform this with several queries, but why do with each query when we can just do this one time and create way more valuable data you can easily search through? So what I'm going to do first is we're going to create new data. So I want a new bucket. So I have my data set, and I'm going to say improved. And we create that bucket there. And we are going to create a Glue job. So I'm going to add the job. We'll give that a name as well. It needs IAM roles, so we can pick the same role we just created. Next, finish. And we are going to work through the data source. And with that is the table we just created. We want to change the schema. We want to make it more searchable, more easy to search through. And we want to put it in its new bucket. So it gives you a pretty picture on the screen saying, okay, I've got all this nested data. Let's go and just flatten that all out. And I'm say save job. I say run job. And Glue is now going to get to work. So what did I just do? This is a job. And jobs within Glue are basically the meat and potatoes, as you would say. Glue is an ETL, extract, load, transform tool. And Glue jobs are where you put that logic, whatever you want to do with data, and apply it to your data. So that's exactly what I'm doing now. I have this nested JSON data, and now I'm going to turn it into flattened CHV. That makes it very, very easy to demonstrate and search through in a demo like this. But it can be transformed in all kinds of things. For the people that know, it can be turned into Parquet. It can be turned into all kinds of different things. It can be exported into a database like SQL or Redshift, which is the Amazon columnar database sort. So you can do all kinds of things with that. So let's see how that went. Let's go to jobs. It succeeded. So let's go to the buckets and see what we have now. It created new files. So let's grab one, let's download it, and let's open that up as well. So we had that raw data here, and now we have flattened CHV. So we're going to quickly put together another crawler, because this is new data and needs to be processed in its own way. Improved. Next. Next. We already have a role, so we can select that now. On demand. Into that database that we already created. Finish it and run it again. So we've now flattened this data, and using jobs, we can do even more. So while this job is running, I'm going to show the new console, which is very pretty, but takes a bit of time to set up. So for instance, I want to move from S3 or Kinesis SQL to kind of the same. So for instance, I want to go from S3 to S3, and then I can create all kinds of transforms here using the UI. I can do mapping, which let's select the current database while it's running. Table. Now it knows the mapping, and I could say, yeah, that's nice, but I want that to become something else. This needs to be user 2 when I export it. Or I can say I want to select specific fields that I want, or I want to drop specific fields. So I can hook multiple transforms up to this setup and do multiple steps, multiple stages. So this is a very powerful tool, this Glue Studio. So let's go back to the crawler. Yeah, it finished. It's created a table. So let's take a look at that. Improved. And now you can see all of it's been flattened out. So let's go to Athena. Let's refresh it. Let's do a quick preview table on that. And now you have all these columns. So if I take these columns and I prepared a query in advanced, because now you want to start getting data out of this. So what I did here is grab the states that a user is in, and then count them as well, and then order them to find out where are people coming from. Let's run this. Nope. I have the wrong query. It is cloud web app user data improved. Run. Now we can see that if this were to be a web app, for instance, a online store, that most of our customers seem to be coming from the Netherlands, because these are all Dutch states, provinces. So let's go further. Okay, so we're a Netherlands store. We expect them to come from the Netherlands. So what's next? Suddenly I'm seeing Australia. So why is our store so popular with Australia? That's very interesting, because it's apparently more popular in Australia than it is in Germany, for instance. Because these are the states that I'm now seeing. And below that, now I'm going to see US states. So this already in about 10 minutes gives you raw data and already gives you feedback. You already start figuring out where your customers are coming from, and you can adjust your web store or your application to fit that. You have a good German user base, so translating your website to German might be very valuable, for instance. So you're now here. So what's next? Machine learning. At this point, you have your data, and you are starting to do some basic querying against it. But what about combining them? What about predicting things? What about all kinds of predictive algorithms that you can tell things before they even happen, for instance? Machine learning can do that. And I will then give the floor over to Herman, who will give a good talk about that.
Thank you, Nick. I will start also my camera. So I have to change the settings. So my name is Herman Kiezenbrink. I'm 32 years old, working for SoftwareOne. First, I will introduce myself and our company. After that, I will tell you something about AI, and at last, how we help companies with the roadmap on data and AI. So after my study economics, I started as a commercial business analyst at the oil company. I had the responsibility to take all the kinds sources of data, bring it together, analyzing and looking into patterns. My responsibility was demand forecasting. After that, I started for Capgemini as account manager and I did some AI projects for them. I liked it so much, and that was also the reason why I joined SoftwareOne to set up a data and AI department. So let's go further. Yes, so, SoftwareOne and HeleCloud, where we were in the beginning, where we were only a reseller. We are now transforming to a service organization where we do the inspire phase and inspire and design phase and the buy phase. We joined forces with HeleCloud, and they will do the services phase 3 and phase 4 to implement and build and optimize and manage the services. The innovation landscape from SoftwareOne, in the downstairs you see the ELT processes. So we help companies create pipelines with the ELT. We help companies with data platform, data lakehouse, and that kind of things. On the left side up, you see data presentation. Right up, you see data science and machine learning. And on the right, you see automations, and there we help our customers with RPA. So the question, what you can predict with AI? For example, you can predict when the machine needs maintenance, or you can predict the fraud protection. But maybe customer behavior is very important for your company. So you can predict when packages come too late to your customer. But you can also predict the demand forecasting. So how much is your house worth in 6 months, or how many shirts we have to buy in, because football clubs can only buy 2 times a year the amount of shirts, so they have to predict it very precisely. And after that, you can also predict football analytics. What will the chance be the chance of a player to score in this match? So in Faro Energy, I was responsible for the demand forecasting. We had a lot of data for the department supply, trading, sales, terminals, and we have to bring all the data together. Our target as organization was margin optimization. So for the supply department, water levels, both in time, both prices, etc., were very important. for the margin. For trading, it was very important to buy optimal time the products. For the sales department, they have to set up the right price, and for the terminals, they are having the right stock given the market situation. So, if we are a bank, a question: how can we estimate whether Peter can repay the loan or not? So, are we giving to give Peter a loan or not? So, the gambling behavior of Peter makes sense. How long does Peter work somewhere on average? Makes sense. Being in the red, do he have debts? Makes sense. Is he married or single? All this kind of futures have an impact if he can pay his loan back or not. So this will help us to make a decision if we can help Peter to give him a loan or not. So a lot of sources of data have impact on this prediction. But another one, what affects demand for soccer shirts? So how many shirts shall we buy this year? I told you before, you can only buy 2 times a year a t-shirt for the soccer clubs. So the popularity makes sense. The out shirt color, I don't think it makes that many sense, but I think it will have an impact on the prediction. But also the number of fans of the football club, number of club members, traffic on the website, sales the previous years, a result of the players, number of viewers, new registrations, new acquisitions, marketing actions. All these kind of things will have impact on this prediction. So you have a lot of sources of data, and from all kinds of systems. But how you are bringing this together and how you're gonna analyze all this data, it's very difficult, because maybe you use Microsoft Dynamics, you have data on your Google Cloud, in your Microsoft Azure, in your AWS, Salesforce, SAP, Workforce, Oracle. So you have a lot of sources of data which you have to bring together, and that can be a data lake, a warehouse, or a data lake house. You can analyze that and make a prediction. So AI helps you to recognize patterns from large amounts of data. So all the sources of data is very difficult to read it all by hand. So you have to combine it, make cross steps, but machine learning can do that also for you. So he is a lot of faster and a lot of better than you, and see much more. And what we do at SoftwareOne, so we give into our clients inspiration session, and we help to understand their data and AI roadmap. So we start the meeting with telling something about data and AI. Then we show what's happening in the market and industry. Then we show some use cases focused on their market of the customer. Then we show some use cases focused on their type of organizations, and then we're starting discovering problems of the customer. After that, discovering use case, and we create some use cases with the customer. After the first session, we will deep dive in the use cases and look what the return on investment can be for the client. So how we do that, we start always with a value proposition. So it's very important that AI is combined with business strategies, the business initiatives, and the risk and critical capabilities of the organizations. So for example, if customer behavior is very important for you, because you have a small group of clients who sell a lot, who buy a lot, I mean, so customer behavior is important for them. So in that way, we can look if we can predict the how late the packages will be arrived at the customer to have the satisfaction so high as possible. So we're starting with the value proposition of the customer, so we know their goals, and then what we are doing here you see a plate. This is for one of our prospects. What we do, we go, we paint out a data roadmap of the client, or where all the systems from the clients are in, and we look then where machine learning can fit on their problem. So with this paint, we go in touch with Amazon or other vendors, with the data scientists, to show them this picture and go in conversation with them how it can help the client. So you have two parts of machine learning. One for the data scientist, so he will focus on deploy, predict, monitor, and optimize. So that's more the technical and the Python part, as you can see here. So he can work on access ML data, prepare the data, build ML models, train and tune ML model, and deploy and monitor the results. So, but we are also creating citizen data scientists, that are people with domain expertise, who know where they have to look to which kind of sources of data, and can start to data engineering. So they know already the data, so they own already the data. So they can pick a target, analyze the data, create a model, generate and understand the predictions, and give it then over to the data scientist. So that was my part. I will give the word on Angel. Thank you.
Thank you, Herman. Okay, can you see my screen?
Yeah, we can.
Okay. Well, thank you for joining us. My name is Angel Conde. I came from the research industry before joining AWS. Well, I have been working with data lakes, Industry 4.0, and all that kind of technologies. I was leading a research team here in the Basque Country in Spain, and well, I joined AWS as a senior solutions architect, specialized in data analytics. And the idea of the presentation that I will be running right now is just to have the point of view of AWS and how can AWS help you on getting value from your data. Let's start with the presentation. Well, first an idea that the next wave of innovations will be driven by data. What does this mean? This means that, for example, that imagine that only the 50% of businesses who were on the Fortune 50 100 list in 2000 are still there today. And well, the introduction of the cloud over the cost of storage and computing at scale, and as a result, it's a set of a generation of automation. And now, as new ways to process and large volumes of data become simpler and more cost effective, we see the next wave of innovation being driven by data. So, building a data strategy and data-driven organization is an imperative way to stay relevant now and in the future. But well, so what does a modern data-driven organization like this look like? Well, a data-driven organization means that first, the data is an organizational asset. For example, you no longer keep the data in silos or as a property of individual departments. The data is accessible. I mean, anyone that's in the organization that need to access the data can access it in an easy and secure way. And the last aspect is the data is put to work. I mean, you can use analytics, machine learning to make better decisions, create efficiencies, and drive new innovations. The problem with this is that nowadays, more data than ever is being generated. I mean, every year we have more data than the prior 30 years combined. I mean, to hold that on-premises tools and data storage are not going to handle this kind of scale. Another problem and challenge is that data of all types is stored in different silos for multiple data storage. The third one is that machine learning is challenging. The adoption of artificial intelligence is challenging because the lack of skills or organizational inertia. And then one aspect that is combined is that you need to comply with security, privacy, compliance regulations, and we have more and more of them. For example, the European GDPR for protecting personal data, and you need to comply with that in order to be able to store and analyze your data. Well, what's the point of view of AWS of this kind of challenges? Well, the idea is to modernize, unify, and innovate in a way in order to have like a modern data strategy. I will introduce each of these points. The first point is that modernize. Here, modernize means that you will migrate your data infrastructure with the most scalable, trusted, and secure provider. For example, here, the idea here is that, for example, just to imagine our customers usually break free from legacy databases. They move to, for example, to legacy Oracle or another kind of databases to cloud managed databases that are cheaper. They are moving to fully managed database analytics services. I mean, usually the companies doesn't want to spend time in services and just they want to use them and just pay for what they use. Also, they organize their data warehouses and that try to move after use the competence. Okay. Well, just to get you an idea of an example, over 400,000 databases have migrated to the clouds just using AWS database migration service. I mean, this is just one service for doing one-shot migrations and real-time synchronization between databases. Mind that this number will be a lot higher because there are a lot of tooling there, and some customers will use their own tooling or their own methodologies. For example, just to take an example, take Samsung as an example. They recently broke free from Oracle, migrating 1.1 billion users to Amazon Aurora across 3 continents and put the database costs by more than 40%. I don't want to be technical here because I think it's not the way, but just to imagine that you have a lot of different services in the AWS that can fit different traditional databases, and you can have like direct mapping from the open source managed by AWS, open source alternatives. Okay, and that's the take on AWS, is that one fits nothing at all, because we can have like a single database system that can optimally handle every single workload, and that's why we have different things and different services to provide all the use cases that you will need. Well, the second point of the modern data strategy at AWS is that unify. I mean, just put your data at work with a secure and governed access to data, using the best of both data lakes and purpose big data storage. And for this, we have the so-called lakehouse approach here at AWS, and that means, as Nick said on the first part of the talk, you will use like Amazon S3 as a data lake, where you will store all your information. You will have around the different purpose data services. Here, for example, you have different Amazon Aurora, DynamoDB, that is an SQL solution. You will have also Amazon SageMaker, as I said, about artificial intelligence, REST, that's a managed data warehouse. You will have unified data access. We have a service for that that will unify the data access and unified governance, that is lake formation. And the idea of all of this is that they should be performant and cost effective. Well, as I said, we have a lot of purpose big data services around the lakehouse approach that this will be based on S3. Say Amazon Athena, that's also Nick saw it, that is a serverless interactive query server service. Amazon EMR, that is our Hadoop alternative, or Hadoop managed Hadoop alternative. Amazon Elasticsearch for log and analytics. We have Kinesis and Managed Kafka for real-time analytics. Redshift for data warehousing. And the idea here is that just to try to break down data silos, I mean, move your data at the scale to where it should be. I mean, and just try to get value from it. And we have like you can have like extraction from those scenarios. For example, Nick also showed Glue that can be used for that. You have visual data preparation tooling or services in AWS. Nick also showed that in with the Glue Visual Studio. That you can have also very easily you can set up data replications from, for example, just if you want to make move data from your data warehouse to the data lake backwards. And another thing that I think is very important in the kind of scenarios where you have the data stored around is that we provide a lot of services with federated query. I mean, if you are you can query data in Athena, using Athena that is stored in a relational database. If you are inside of AWS, I mean, it's just try to break those data sets. The last point of how we approach the model data study is that innovation. I mean, and for that, the idea is to build in experiences and remind all processes with artificial intelligence and machine learning. And well, we just I just put it here some examples. With some of the services that you can use. We provide different services, level of services. We provide to build your own, but also have high-level artificial intelligence services that you could use. For example, this one for personalization, we have Amazon Personalized. For intelligence, we have Amazon Kendra. If you want to try to analyze metrics analysis, we have Amazon Lookout for metrics. For fraud detection, we have Amazon Fraud Detection. So those are high-level artificial intelligence services that you can use for or for new use cases. And one of the key ideas here of AWS is that with the concept of data lakes, the concept of having the data there stored is that you can have the idea is that we provide tools to bring machine learning closer to your data. For example, you can use customize machine learning models directly calling them from Redshift, that is your managed services, or Amazon Aurora. You can have like with an SQL function, you can call a machine learning model that is stored in SageMaker and just have the inference or just train the model again directly with SQL tooling. And the final aspect is also we have for business intelligence tool, we have a service for visualization and reporting called QuickSight. And there also we have integrated a lot of machine learning and artificial intelligence there. For example, you can have, without knowing anything about machine learning, you can have forecasting. You can try to ask questions with natural language processing. For example, how is the forecast for the next quarter? And it will be processes. It will understand the question that you are asking, and you will provide the output. Well, you have here the different services. For example, that I was telling you that we have integrated in a lot of this data analytics services. We provide machine learning capabilities. And well, that's the recap. Just to imagine the point of view of AWS and the things that the tools that we provide on services is that the idea is just to modernize, unify the data access that you are storing there, and finally, just to innovate with artificial intelligence and machine learning. Well, that's it. That's the end of the presentation. Thank you for your time. I don't know if you have any questions about it, but if not, I will let maybe Eva want to talk. Okay.
Yeah, if you have any questions, please put them in the questions box.
Can I still be heard by everyone?
Yeah.
Great. So my webcam doesn't want to turn on, and I have a very big button in my screen that says that the app will stop, and I don't want it to, because I want to talk with you fine people. So while people are able to ask their questions, there's a field in the webinar that you can ask questions in. I have a question, basically to both Herman and Angel, whoever wants to pick that up. And that's how would someone that's not doing any data analytics but is gathering things like logging, how would you suggest they start this journey of data analytics?
So, sorry, your question, can you repeat it, Nick?
Of course. What I asked is, what would you, when you have a customer that's not doing, what would you recommend to a customer that isn't doing any data analytics yet, but does have a lot of valuable data? How would you suggest them to get started? What would you say, how they would, what would be their first step?
Yeah, so thank you. So we do also some services about the data majority of the customers. So we make a plan of the data majority, but where they have to start is to know which data is important and where they have to look at. So you have a good feeling about where the value of the data is in which kind of system, and then you have to think how you will bring all the data together and centralize all the data, and also let the data talk with each other. So I think that's the first thing on the roadmap. We start with customers, but Angel, maybe you have another insight.
I think that you say was the right approach. I mean, you start trying to upload the data, for example, to raw data to S3, as you saw, Nick, in the demo, and then try to just to transform in a usable format, and then you will try to extract and just getting value from it using machine learning. But I mean, the demo, I think the process will start just to storing the raw data, as you saw in the demo, and then just try to transform it in usable formats, and then you will need to think about first. I think the machine learning is first thinking about the business case. I mean, trying to, instead of working first with the data, you need to think about, okay, I have this data, but first you need to start to think about what's the real use case there before trying to achieve anything.
I actually also have a question. So some bigger organizations already have a lot of data, but sometimes this data is not stored properly. So you have a lot of data that is not stored in a proper way. How would you advise those companies to start with analytics? Because I think it can seem quite a big challenge, maybe too big of a challenge. But at the same time, all of the data can be very valuable.
Totally agree. Herman already touched upon that, so I think he's a good one because in that entire process he shared. But mapping or doing a data discovery would be the first step. We focus a lot on AWS right now, but the tooling I showed there, the crawlers and the jobs, they can ingest to and output to so many different platforms. Combined with other services like, for instance, Kinesis, getting data out of a system and combined somewhere centrally, that would probably be my first step. And that doesn't have to be S3 specifically or AWS, but gather your data. Don't keep it in 1,000 different places. Start bringing it together so you can have one single method of organizing rights and access, auditing performance, just centralize and standardize would be my recommendation.
Thank you.
Yeah, I think adding from what Nick said, I think like apart from having the data catalog for very big companies, it's very useful to have like a data quality strategy, because usually you end up with a lot of data, but that is not usable for the data scientists. Sometimes that data is old or having refreshed from which, because nobody's looking for, okay, this data that came from this ETL batch job hasn't run well from 1 month. I mean, it is very important when you have a lot of data there and you are a big company to have like a data quality strategy apart from the data catalog.
Yeah, totally agree on that.
Me too.
Anything to add, Herman?
No, nothing to add. I think you said, yeah, the same thing I say.
So one thing I think I would love to add that kind of hooks into this is, especially AWS is getting more and more functionality from a compliance and a security perspective, where you can keep all your data in the same place, and you can give the access to the same data from that same place, but by using row or column or even cell level security, you can have different people get different results from data, because someone from auditing would need a lot of information, but someone from sales has no business knowing personal information from a customer, for instance. And being able to limit that while keeping all your data in place and untouched is extremely valuable and also very quick to set up. The devil's always in the details, but being able to do that